Hello, I'm Benson Chan, co-founder of Strategy of Things. I'm coming to you live from CES 2024. Today I'm joined by Larry Socher. He's in charge of strategy and partnerships at Eseye. Larry, welcome.
Great. Great to be here, Benson. Thanks for having me. I'm responsible for strategy and alliances at Eseye. We're a global IoT communication software company. Our real sweet spot is delivering secure, resilient global connectivity, predominantly cellular. And we service a lot of large customers who really have big footprints, like Amazon Keys for Business, Coca-Cola, Costa coffee machines. So it's a very big, large people who need a deployable, secure, reliable communication solutions globally.
Oh, great. Larry, wanted to ask you about multi-RAD.
Okay.
What is it? You can explain that.
This has been a passion of mine for quite some time. So multi-RAD stands for multiple radio access types, and the concept is basically using multiple access technologies, so wireless access technologies to solve different problems, because some of them are better suited for certain kind of use cases and others are not. Now, not a new concept. I mean, we all have our iPhones or our Samsung Galaxies. These have been multi-RAD devices for quite some time in the consumer world. I use this for cellular communications, all my voice, video, data that goes over that. Wi-Fi when I'm in the home, so I can take advantage of the broadband network. Bluetooth, if I use Bluetooth to talk to peripherals, my headsets, etc. NFC for payments, I was just using for my hotel access this week. And even these keep expanding. UWB for finding stuff. If I think about the different devices like the AirTags, for example. And then finally, they're even starting to go to satellite. If you think about what Apple did recently with Global Store and the SOS features. So these have been multi-RAD devices for a while. I think what I really get excited about is as the price points come down in modems and driven by a lot of the explosion of devices in the digital home, we're going to start to see much more of that in the IoT world. And that's where we get very excited.
Is price the only driver for more of these, or are there other considerations?
Yeah, I mean, cost is clearly one. How can I take advantage of a lot of deployed technologies that have been, the cost structure has been driven down in the digital home? But one that's actually more important in my mind in many cases is resiliency. By using different technologies, if I have a problem with one network, I can always switch over to another network. So I can actually, by mixing and matching different networks and protocols, I can actually get a much more resilient environment. So a great example is we do a lot of work with remote patient monitoring companies. And to date, those companies, like if I have a heart monitor, they typically are either Bluetooth or Wi-Fi in the house, or then they're cellular on the global market. Now, if I could take a heart monitor and I have a Wi-Fi modem in it, and I also have a cellular modem in, what I can then do is use the Wi-Fi network I'm in the house, take advantage of an existing network that's becoming increasingly more reliable, large broadband connectivity. Then if connectivity gets degraded or it starts to, there's an issue, there's a power failure, I can then switch over to the cellular. Or when I leave the house, I can go on the highway, I can then use the cellular. And then that can even be more interesting, where if you're following some of the new 3GPP, the GSMA standards for cellular technology, they have something called Release 17 non-terrestrial networks, and that allows me to use a standard cellular modem, or R17 enabled cellular modem, to actually go up to a constellation of satellites or geostationary satellites. So with just a Wi-Fi modem and with a R17 enabled cellular modem, I can run in the home broadband network, leave the house, go on the highways, run on the terrestrial cellular networks, your public cellular networks, and if I go up into the mountains or somewhere that's out of terrestrial coverage, I can go to the satellite. So there's a great example of just incredible resiliency, almost ubiquitous global coverage as R17 rolls out, just with two modems, two radio access types, and kind of three derivatives.
Now, are there other use cases? Resiliency is kind of a huge thing, right?
Yeah, and you think about it, like remote patient monitoring, you can't get a more resilient,
right.
You can't afford to be down, and just the ability to be able to switch between the networks. So if either one fails, if I lose connectivity, in the case of cell, if I go to the basement of a house, I might not have cell coverage. So you really need to be able, if you can mix and match these use cases, you get increased resiliency. It's just if there's interference with one frequency range, it's not in the other with the other protocols. So resiliency and cost are the primary drivers, but there's power savings, there's other, you can use low powered stuff when you're operating on batteries. So what's interesting about IoT is every device device and use case is different, right? So you can mix and match these and tailor them to the specific requirements of the application.
So where's all this headed? I mean, it seems pretty exciting. It seems like IoT coming in. There's a lot of opportunities. Where's the next growth?
I think it takes IoT to the next level. I can do things that I may have been a little bit trepidatious about. Hey, if it's life and death situations, I can, by mixing and matching these protocols, I can get a better cost structure, more resiliency, as we talked about. I mean, one of my favorite emerging use cases is, we do work with automobile video monitoring companies, and a lot of those video monitoring also do automobile maintenance. They have an interface into what's called the ODB interface that gets instrumentation from the car, and in doing that, they've got a bunch of data. Now, they upload that data to the cloud, and that data use case can be for a car maintenance, predictive maintenance. It could also be, if I'm in an accident, et cetera, and stuff like that. But if you think about it, it's taking that same thing I described earlier. But if I had Wi-Fi and an R17 enabled cellular modem, the great thing about that is when I'm driving on the highway, I can submit amount of data. I've got cellular technology. It's relatively cost effective. I can send pictures every now and again, some data instrumentation. If I'm up in the on a more expensive satellite network, I'm only going to spend critical alerts or critical events. I'm going to do something that very much limits that. But then when I get back in the house, I can upload all the video and all the other instrumentation and stuff like that to the cloud for analysis. So you can actually mix and match those different protocols. Start to address different use cases without blowing out the economics in a very intelligent way. And then but depending on what network I'm on at what time, I'll have a different set of capabilities.
So that sounds all pretty interesting and exciting. But what are some of the challenges in deploying something like this?
Yeah, and it's a great question, and that's where we're spending a lot of time at Eseye right now. Is really the first thing is device intelligence. You really need much smarter software on the device. So software that not only knows, hey, I'm on a cellular network. How expensive is it, et cetera. What's its capabilities? How much bandwidth I have? How much latency? Can I send all my video data up, for example? Or I'm on the satellite network. I've got low bandwidth. It's very expensive. I don't want to send this stuff. So you need the intelligence to do that. You need the intelligence to switch between the networks. So when I know when I leave the home network, I know when I leave the cellular network, although that's still available in the house. But when I get in the satellite network, once I get back on terrestrial, I need to switch back. So to be able to switch and select the network technology is one of the big intelligent things. And then also have an understanding, be able to actually have APIs to the applications that says, hey, you're on an expensive satellite network, it doesn't have a lot of capacity, only send critical events. So just intelligence to do that switching, the selection, the optimization that is ideally done by a rules engine that on a connectivity management platform that can send out. But then even providing APIs to the application so it knows what data to send when. Hey, I'm not going to send all my video until I get back at the house and I got a broadband network.
Now, if someone's considering something like that, what advice do you have for them?
Well, I'd like to say call us. We're looking at this. We're definitely looking for customers and talking to a lot of people with these use cases. But start with a device. I mean, that's actually been the big lesson we've learned over the last few years. We've always done a lot of device work, but if you don't get the device design right up front and understand the connectivity and the different options and do that well in a flexible way that can introduce the next technologies, that's where people seem to run into roadblocks. I mean, Kaleido Intelligence did a study about a year and a half ago where they interviewed people about challenges of global cellular connectivity, and there's all the roaming and localization and regulatory challenges, but 84% of the respondents came back with, hey, device design is the hardest thing. And so I think start with the device design, really focus on that. Also look at the art of the possible. There's a bunch of emerging technologies. And I'm a big fan of mixing, as you heard, mixing and matching technologies to solve the problem. Don't just think, hey, what can cellular do this? Can Wi-Fi do this? What if I mix and match them? Now that modem prices have come down in price, what can I do can I mix and match them to hit both my resiliency, performance, and cost, parameters?
Well, Larry, thank you. It was very informative. I learned some new things myself here. Thank you for being here and speaking with me. I know you're here at the show. I hope you enjoy the rest of the show.
Great. Thanks a lot, Benson. Really enjoyed it, and looking forward to the rest of CES.
Thank you.